video. Today we will explain about descriptive statistics, measures of dispersion.
In this material, we will explain about range, variance, and standard deviation.
But before that, let us introduce ourselves first. My name is Adina Karen Sasiami and my student ID number is 096.
My name is Della Angelica and my student ID number is 097.
And my name is Nandita Rizky Abadi and my student ID number is 093.
We hope you enjoyed the video. Let's get started.
Measures of dispersion. What is measure of dispersion? A measure of dispersion is a way to measure how much the data values vary or spread out. It helps us understand whether the data points are close together or far apart. There are three main types of measures used to do this. The first one is range, the second one is variance, and the third one is standard deviation. Let us start with range. What is range? Range is the simplest way to measure how spread out the data is. It works by finding the difference between the smallest value and the largest value in the dataset. For example, if the data is 7, 9, 8, 11, 4, 5, you would identify the largest value, which is 11, and the smallest value, which is 4. Then subtract the smallest value from the largest value, which gives us 7. This means the range of the data is 7, indicating the distance between the largest and smallest values. The range only considers the two extreme values, largest and smallest, and ignores all other numbers in the dataset. This makes it simple but less comprehensive. The next one is variance. Variance is a way to measure how spread out the data is from the average or mean. It looks at how much each number in the dataset differs from the mean, then squares these differences. Imagine you have a group of numbers. The mean is like the average of all those numbers. Variance helps you see if the numbers are close to the mean or far away from it. A larger variance means the data is more spread out from the mean. A smaller variance means the data is closer to the mean. The formula for sample variance is: take the sum of the squared differences between each data point and the mean, then divide by the number of data points minus 1. While for calculating variance of population, you would divide by n instead of n minus 1. For example, we need to calculate the sample variance for the dataset 5, 10, 15. Here are the steps. Step 1. Find the average or mean. To calculate the mean, add all the numbers together and divide by how many numbers there are. The mean is calculated by adding 5, 10, and 15, then dividing by 3. So 5 plus 10 plus 15 equals 30, and 30 divided by 3 equals 10. So the mean is 10. Step 2. Find the deviations from the mean and then square them. Subtract the mean from each data point and then square the result. For 5, 5 minus 10 in parentheses squared, that's negative 5 squared, which equals 25. For 10, 10 minus 10 in parentheses squared, that's 0 squared, which equals 0. For 15, 15 minus 10 in parentheses squared, that's 5 squared, which equals 25. Step 3. Add up the squared deviations. Now add all the squared deviations together. 25 plus 0 plus 25 equals 50. Step 4. Divide by n minus 1 or number of data points minus 1. Since there are 3 data points and minus 1 equals 3, minus 1 equals 2, divide the total squared deviations by 2. So 50 divided by 2 equals 25. So the variance for the dataset 5, 10, 15 is 25. This means the numbers are fairly spread out around the mean 10. Now, we move to standard deviation. Standard deviation is the square root of the variance. It is more useful than variance because it gives us the spread of the data in the same units as the original data. To calculate the standard deviation, you must first calculate the variance and then take the square root of the result. To understand standard deviation, let's continue with the example we used for variance. We have a dataset 5, 10, 15. From our previous calculations, we found that the mean of the data is 10 and the variance is 25. Now, to calculate the standard deviation, we simply take the square root of the variance. Since the variance is 25, we take the square root of 25, which gives us 5. The standard deviation tells us how much the individual data points differ from the mean on average. In this case, the standard deviation is 5. This means that, on average, the numbers in the dataset 5, 10 and 15 are about 5 units away from the mean, which is 10.
Alright, let's talk about mean deviation. What is it? Mean deviation is the average distance of numbers from the mean. It is small when numbers are close to the mean and large when they are spread out. For example, the data is 3, 6, 6, 7, 8, 11, 15, 16, and we have to find the mean deviation of this data. Here's how to calculate mean deviation. Step 1. Find the average or mean. Add all the numbers and divide by how many numbers they are. The mean is calculated by adding 3, 6, 6, 7, 8, 11, 15, and 16, which give 72. Then divide 72 by 8, which equals 9. So, the mean here is 9. Step 2. Find the distance of each number from the mean. Now, let's check how far each number is from 9. The mean, which is 9, and ignore the minus signs. The first value is 3, and its distance from 9 is 6. And do the same with other values. So, the distances from the mean are 6, 3, 3, 2, 1, 2, 6, and 7. Step 3. Find the average of these distances. Add all the distances and divide by how many numbers there are. To find the mean deviation, we add up all the distances. 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 7. That gives us 13. Then we divided 30 by 8, which is the total number of data points. So the mean deviation is 3.75. Next, let's talk about absolute deviation. Actually, the mean deviation is sometimes called the mean absolute deviation or MED. It tells us how far, on average, all values are from middle. From the latest examples, each distance we calculated is called an absolute deviation. Example, the absolute deviation of 3 value from 9 is 6, and the value 16 has absolute deviation 7. As we can see, to show absolute value, we put bar mark. The symbol from sum up is called sigma. Then, we sum up the absolute deviation to get the mean deviation. We will check the deviation on one side of the mean should equal to the deviation on the other side. From our example, the deviation left of mean is 6 plus 3 plus 3 plus 2 plus 1 is 15, and the deviation right of mean is 2 plus 6 plus 7 is 15. So, both sides are equal. If they are not equal, you may have made a mistake. Next, the coefficient of variation, or CV, is a measure of relative variability. The CV is useful when you want to compare results from two different surveys or tests. For example, comparing two multiple choice tests with different conditions. So, comparing standard deviation doesn't really work because the mean are also different. Then, calculating using the formula of coefficient of variation. For example, first, we divide standard deviation and mean of regular tests, then times with 100. So the coefficient of variation for regular tests is 17.3. Next, we divided standard deviation and mean of randomized answers. Then we times with 100. So the CV for randomized answer is 28.35. So the result can be more significant.
Alright, next, let's talk about the Index of Qualitative Variation or IQV. It measures variability for nominal variables like race or ethnicity.
It shows how evenly cases are distributed across categories. If IQV 0.00 means no diversity, all cases in one categories. If IQV 1.00 means maximum diversity, cases evenly distributed across categories. So this is IQV formula, where K is the number of categories, N is the total number of cases in distribution, and sigma PCR square is the sum of all the squared percentages in the distribution. Let's take example on Maine versus Hawaii. In Maine, the population is mostly white, 98.4% with very small percentages of Latinos, 0.8%, and Asia, 0.8%. Meanwhile, in Hawaii, the population is more balanced, white 33.5%, Asian 55.1%, and native Hawaiian 11.4%. To measure this diversity, we need to use IQV formula. So let's break that down. Please take a look on the formula right here. Maine IQV calculation. K is 3, which is Latino, white, and Asian. Percentages: white 98.4%, Latino 0.8%, and Asian 0.8%. Step 1. We can take the percentages of each group, square them, and then add them all together. And then for step 2, subtract the total sigma p squared from 100 squared. Now, multiply this result by k. Finally, divide by 100 squared times k minus 1. Maine's IQV is 0.05, indicating very low diversity because nearly everyone belongs to one group, which is white. And Hawaii IQV calculation is K is 3, which is white, Asian, and native Hawaiian. Percentages: white 33.5%, Asian 55.1%, native Hawaiian 11.4%. Step 1, we can do the exact same step with the previous formula. And for step 2, we can do the rest of the formula like before. Just follow this formula and you will get the last final answer. Hawaii's IQV is 0.86, showing high diversity because the population is more evenly distributed across the groups. How are we expressing this as percentage, if you might ask? We can multiply IQV by 100 to get the percentage of actual diversity compared to maximum possible diversity. For example, IQV 0.86. We can multiply them by 100 to be 86% diversity. Now let's talk about ordinal variable. First thing, like ranks, where the order matters, but the difference between values isn't consistent. We can use IQV to measure variability for ordinal data, but there's a problem. IQV doesn't consider the order of values. For example, it treats first, second, and third the same as third, second, and first, so it loses some information. An alternative to this is interquartile range, or IQR, which focuses on the middle 50% of the data. It's also a great way to describe the spread of data because it respects the rank order. And then, let's look at interval ratio variable, like age or income, where both the order and the differences between values matters. For this variable, you have three options. There are range, interquartile range, or IQR, variance or standard deviation. So, what if the data is skewed? Skewed means there's an extreme value that throw off the average. And use range or IQR is a better choice because it's less affected by outliers. So in conclusion, measure of dispersion helps us understand the spread and consistency of data within a dataset. These includes the range, variance, standard deviation, and mean deviation, which show how far the data points are from the center, whether it's the mean or median. The IQV, index of qualitative variation, adds to this by measuring diversity on scale from 0, no diversity, to 1, maximum diversity. For ordinal data, the interquartile range, or IQR, highlights the middle 50%, while variance or standard deviation works best for interval data. In cases of skewed data, the IQR or range provides a more accurate representation. I think that's all from me. Thank you very much.
That's all for our video. Thank you so much for watching.
Wassalamualaikum warahmatullahi wabarakatuh.